We've just launched the Full Fat Podcast, where we talk about movies, games, TV, and news. So if you want to catch it, why not log on to Spotify now? The link is in the description below. This is a clip from an episode of The Simpsons entitled The Wizard of Evergreen Terrace, which aired as part of the show's 10th season. In it, desperate to become an inventor like his newfound idol Thomas Edison, Homer jots down 4 equations on the board as he contemplates his next big idea. Whilst each equation is legitimate, the top equation for example comes eerily close to predicting the exact mass of the Higgs boson particle, it is the second equation which continues to prove the most interesting. A simple formula containing 3 numbers each to the power of 12, a quick input of this sum into calculators reveals the equation to be balanced. At least at first glance. But for those with an interest in mathematics, this blink and you'll miss it maths gag reveals that Homer may have done something thought impossible, found a solution to the infamous problem of Fermat's last theorem. Let's explain the context for this. Pierre de Fermat was a French lawyer who was alive during the 17th century. Despite this being his occupation, Fermat also practiced maths problems in his spare time and is widely credited for early developments that led to the study of calculus. In 1637, Fermat was scrolling through a book called Arithmetica, written by Diophantus of Alexandria in the 3rd century, when he came across a puzzle revolving around Pythagoras' theorem. Pythagoras' theorem states that the area of the square of the side of the hypotenuse is equal to the sum of the areas of the squares on the other 2 sides. But Diophantus challenged readers to find whole number solutions to the problem, such as 3 to the power of 2 plus 4 to the power of 2 equals 5 to the power of 2. Inspired by this problem, Fermat decided to challenge himself to find whole number solutions to cubed variants of the Pythagorean theorem. Fermat found that he could not find any solutions to this equation using whole numbers. Moreover, if he increased the value of the powers further, he could not find any solutions to these equations either. Following further interrogation, he theorised that this was because there were in fact no whole number solutions to this equation. Of course, such a broad sweeping statement required a degree of proof to be accurate, but Fermat had this partially covered when he scribbled in the margins of his copy of Arithmetica a now infamous statement. I have discovered a truly marvellous proof of this, which this margin is too narrow to contain. Suffice to say, if Fermat had indeed discovered proof, then he had either forgotten or deliberately neglected to write it down. For almost 4 centuries, the answer to this question regarding Pythagoras remained unproven until 1995, when Andrew Wiles published a 130-page paper which finally put the question to rest. However, the equation on Homer's blackboard appears, at first glance, to disprove Wiles' proof. Inputting the equation into a calculator, it clearly balances, but Homer's equation, rather than being a legitimate solution to Fermat's last theorem, is in fact an extremely near-miss engineered deliberately by one of the show's writers, David X. Cohen. When inputted into a proper scientific calculator that could display more than 10 digits, the answer is actually out by a minute margin, which meant that unless the viewer interrogated the equation further, they would be fooled into believing that the writers had stumbled upon a legitimately game-changing mathematical formula, within a joke in a Simpsons episode. Cohen had a strong background in maths, having studied for a master's degree in computer science at the University of California before joining the show's writing staff, and had even changed his name to X Cohen to reflect his love of algebra. In fact, Cohen was not only aware of Fermat's last theorem, but had a somewhat loose connection to the formula's history, having studied with Ken Ribbit, whose work on the epsilon conjecture had proved a stepping stone to Andrew Wiles finally proving the theorem to be true. To find the near answer depicted on Homer's blackboard, Cohen wrote a specialised computer program that would scan for values of x, y, z and n that would result in values that were so close to being equal, it would take a scientific calculator to be able to show their margin of error. After scanning some of the results, he decided on the equation because it had one of the smallest margins of error, and so as a result, would prove hardest to disprove without the appropriate equipment. Impressed with the episode's reception, Cohen remarked that he was happy that mathematicians might be amused by his sight gag, noting that I was so happy because my goal was to get enough accuracy so that people's calculators would tell them the equation worked. He would later go on to co-create Futurama with Matt Groening, which would equally be stacked to the brim with maths references, not least the episode The Prisoner of Bender, which contained a mathematical solution to its plot penned by Ken Keeler, who holds a PhD in mathematics. But this small joke may be his crowning achievement in terms of his long-term fascination with inserting complex mathematical references into the show's episodes. The Simpsons is filled with complex complex gags and extremely memorable stories, but it's moments like this, these tiny jokes that, when examined further, reveal a long and complex referential network to both history and science that continue to cement the show's reputation as one of the smartest and most densely layered sitcoms in television history. Thank you for watching another Full Fat video. If you'd like to see more from Full Fat videos, why not follow us on Instagram and Twitter? Please consider becoming a patron on Patreon. We've got some cool exclusive content on there. Thank you to our $100 patrons, Dr. Chike and Jax Merrick. Chris and I really appreciate it. Until next time, stay milky.